If one of your hard drives died right now, would your data survive? That's exactly what RAID's designed to help with, and it's not a backup. Hard drives fail, and when they do, it's usually at the worst possible time, during work, during exams, or in a production environment. RAID is one of the ways IT systems stay online even when hardware breaks. RAID stands for Redundant Array of Independent Disks. It means using multiple hard drives together to act as one logical drive. The grouping of these hard drives is called an array. The goal of an array is to improve performance, protect against disk failure, or both. RAID is used by businesses worldwide, but it may also be helpful for you at home. There are several RAID levels, and in this video we'll explore the most common ones, along with what each is actually used for. We'll start with RAID 0, as it's the easiest way to understand how RAID works. So earlier I mentioned that RAID is either used for performance, disk failure, or a combination of the two. RAID 0 focuses entirely on performance. It works by splitting data across multiple hard drives, a process called striping. Imagine you're copying a large video file. With a single hard drive, that file is written piece by piece to one disk. With striping, the file is split into chunks and written to multiple hard drives at the same time. One drive writes a part of the file, while another writes a different part. Because the work is shared, the file finishes copying faster. However, RAID 0 provides no redundancy. If one of your drives in the array fails, all the data is lost. So RAID 0 is used when speed matters more than data protection. If you want protection, you can use RAID 1. Instead of splitting data across the drives, RAID 1 mirrors it. That means the same data is written to two hard drives at the same time. Think of it as making two identical copies of a document. If one copy is lost, the other is still available. So if one drive in the RAID 1 array fails, the system keeps running and no data is lost. However, because every piece of data is duplicated, you only get half of your total storage capacity. Two 1 TB drives gives you only 1 TB of usable storage. RAID 0 focuses on performance. RAID 1 focuses on protection. RAID 5 is when those two ideas come together. Like RAID 0, it uses striping to improve speed. But instead of using mirroring to protect your data, it adds something called parity to protect your data. Parity is extra information that allows the system to rebuild data if one drive fails. Instead of storing parity on one disk, RAID 5 spreads it across all drives in the array. If one drive fails, the array keeps running. The missing data is rebuilt using the remaining drives and the parity information. A simple way to understand this is, if you have three 1 TB drives, you'll have 2 TB of usable storage, because one drive's capacity is reserved for parity. RAID 5 requires at least 3 drives and can only survive a single drive failure. If a single drive fails before the array is rebuilt, all data is lost. To protect 2 drives, you need to be using RAID 6. RAID 6 is very similar to RAID 5. It stripes data across multiple drives to increase performance, but instead of one parity block, it doubles the parity. That means it can survive 2 drives failing at the same time without losing your data. RAID 6 requires 4 drives, and the usable storage is always the total drives minus 2. Because 2 parities need to be calculated, you get slower write speeds and you lose double the storage compared to RAID 5. So RAID 6 is basically RAID 5, but a bit safer. If RAID 6 is all about safety, RAID 10 is about speed and protection. It's basically the best of both worlds. RAID 10 combines mirroring and striping. It stripes the data for speed and it mirrors each stripe for protection. That means your data is always duplicated, so if a drive fails, your copy is safe. RAID 10 requires 4 drives, and due to mirroring, your usable storage is half of what you have. Due to this, it can be expensive, but you get good performance and keep your data safe. It is used for when uptime and speed really matter, such as with databases. Thank you all so much for watching, and subscribe for more IT made easy.